Right. Welcome all. 8.1 Introduction to Vectors. This is going to be a section of mostly definitions with a couple problems we'll go through. Uh, some of this is a little bit more visual that I think class will be better for, but it's good that we talk about what these words mean. And I will still show you some visual representation in these problems. So first, what is a vector? The definition for it is that its quantity has both magnitude and direction. Now we don't know what magnitude is yet. You should know what direction is, right? It's when you're going somewhere with it, right? Uh, and what does the vector look like? It looks like this. I'm going to draw it down here because it's going to help us with our next definition of initial point and terminal point. Because this is what a vector will look like. So an initial point is the tail of the arrow, so where we start, and the terminal is the tip of the arrow, where we have that little, what makes the arrow an arrow down there. Okay? That is what a vector looks like. Initial, terminal. You'll hear me say in class and in general through this chapter, standard position. Standard position is whenever we have a vector that has the initial point at the origin. So if we have initial point at the origin, right here, this is considered standard position. And what is direction? Well, direction is the directed angle between the vector and the horizontal line that could be used to represent the x-axis. So direction, whatever theta is right there, that is our direction. We'll be using this a lot in some word problems we're going to be doing. Don't be scared. I know word problems are usually scary, but for this, not so much. One last definition, and it's probably a word you're like, hey, use this to define vector. What is it? Magnitude, it's the length of the vector. Okay, so the distance from here to terminal point, that is your magnitude. 3 definitions about vectors you should know. Parallel or equivalent opposites. Parallel vectors that have the same or opposite direction, but not necessarily the same magnitude. So here, these two are parallel, but obviously B is a little bigger. They're a little bigger. Equivalent vectors, vectors that have the same magnitude and direction. So there. Try to make them the same size the best I could, but yeah, these are A and D here are meant to be the same size. Opposite. Vectors have the same magnitude but opposite direction. So arrows going this way, arrows going that way, same magnitude, just opposite direction. So I gave you 3 vectors. I'm going to draw a vector diagram for each expression. Honestly, whenever you're drawing, do the best you can, but it'd be pretty obvious whenever it's off. Also, if you look in your book in 8.1, which I recommend you do, anytime we're talking about any of this stuff, take a gander at your book. The way I'm going to be doing things is I'm going to be doing the parallelogram method, they call it. And that's tip. I'm sorry, no. Triangular method. I'm sorry, triangle method. I'm not doing parallelogram method. I'm doing a triangle method, which is tip to tail. Okay, so if I have A, use a different color here. I'm going to use black. We have A. I made that a bit too long. Let me fix that a little bit. That was too much. It's about an accurate length. So when I do negative C, so if you see C is pointed up and a little bit left, right? So if it's up and a little bit left, we're going to be going the opposite direction. Okay, so it's going to be somewhere down there. And then 2B. 2B is going to be down, double its length, so right there. So the answer would be take what's left over and from the tail of the original and put it down to where our tip was at the very end. There we have it. So call this negative B just so we can label and know what's up. or negative c rather. Oh, negative c. And this is 2b. There you have it. All right, so we have a problem about Mitchell's swing. He's swimming east at a speed of 3.5 feet per second, and current rivers carrying him due south at a rate of 2 feet per second. Find Mitchell's speed and direction relative to the shore. So I drew north right here as a kind of a reference. So we need speed and direction. So I want to know what this direction is right. Well, sorry, I start with speed first. Speed's right there. And we're going to have to use our triangle rules that we learned in previous chapters. You remember law of sines, law of cosines. And of course, in this case, up a toe, we got lucky because it formed a right angle right there. So we can use tan equal to 2 over 3.5 to find the angle. Also, we can use Pythagorean theorem in order to find this side right here. And if we do that, I'm just calling that x. You'll get the velocity is 4.03 feet per second. Okay, so that's your speed. Now, what's your direction? Well, if you did inverse tan both sides, we do inverse tan of 2 over 3.5. What do you get? You will get 29.7. Now, that's on our answer. So 29.7 is right there. Tell me more about it. So we usually say it in relation to this line right here, this north line. So since we're down south, though, we're going to go to the south line here. So what is this angle right here? Well, hopefully you recognize this should be 90, right? So what's left over from 29.7? It'd be 60.3. So what can we say in regards to its direction? So it's 60.3 degrees south and east, right? Because you have south and east, and it's going to form 60.3 degrees. All right, so we have a problem here with the player kicking a ball. I'm giving you a velocity of 44 feet per second and the angle. Let's just draw a diagram. That's what I did below. Label my x and y. We want to find the magnitude of the horizontal and vertical components of velocity. Now, in order to find that, so if you remember, cosine is adjacent over hypotenuse, right? So it'd be cosine of 33 equals x over 44. Whenever we're doing this too, remember x and y have to be positive. You can't have a negative value for any of these. So it'd be 44 cosine 33 equals x. In order to get your horizontal component is equal to approximately 36.9 feet per second. Vertical sine 33 equals y over 44. Same story. You'll get a vertical component of approximately 23.96 feet per second. Appreciate watching, and we'll see you in class. Bye-bye now.